Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. So we're going to talk about scalar product of a vector. Some textbook also call it scalar multiplication. So we're going to discuss how to find the scalar product of a vector. Before I proceed, don't forget to like, share, and subscribe. If you've not clicked notification bell, I don't know what you're waiting for. Please do so that when I post new videos, you'll be the first person to know. All right, so to multiply a vector by a scalar, you have to multiply each component by that scalar. Is that okay? So for instance, you have to, because I've talked about there are different types of components. So we have the two components, the x and y. We have the three components, x, y, and z. So for instance, you have the two components, x and y, okay? You have a three components, for instance, x, y, and z. So what I'm saying is that if you're multiplying this by a scalar, you have to multiply each component. So if, for instance, you're multiplying this by k is going to multiply x to give you kx, okay? K is going to multiply y to give you ky. Does that make sense? If you're multiplying this by k as well, same thing. K is going to multiply x to give you what? Kx. Will multiply y to give you ky, and to multiply z to give you what? Kz. So that is what I'm trying to say. So you have to multiply each and every one of this. All right? Okay, so usually when a vector is multiplied by a scalar quantity, the magnitude of the vector changes in accordance to the magnitude of the scalar, all right? But the direction of the vector remain unchanged except you're multiplying by a negative scalar quantity. So that means what we are saying is that if the k is minus, so you're gonna have x and y, so it's gonna be you're going to have minus kx and minus ky. So you can see that it's the magnitude have increased, but the direction now is now what? Negative. All right, good. I'm going to write down what I said because I'm aware that students do take notes. All right, so it will be easy for me so that you can also revise as well. So to multiply a vector by a scalar, yeah, we have to then multiply each component by that scalar. Okay, so you have to multiply each component by the scalar. So like I said, if you have k, you having x and y, all right, it's going to give you k multiplied by x, k multiplied by y, and that is going to give you kx, and you're going to have ky. Is that making sense? All right. Or if you're multiplying a scalar quantity a by three component, x, y, and z, so it's going to be the same thing. You're going to have a multiplied by x, a multiplied by y, a multiplied by z, and then it's going to give us what? Ax, ay, and az. Easy, right? Good. Now, but we need to be careful when doing this about the magnitude and direction because we're talking about vectors. So therefore, all right, when a vector, so when a vector is multiplied by scalar quantity, then the magnitude okay, and the magnitude of the vector. So remember we've talked about magnitude earlier. So the magnitude of the size, the magnitude of the vector changes, okay, in accordance, okay, with the magnitude of the scalar. Okay, but the direction remains the same. Okay, direction of the vector remains unchanged. Okay, except, so this is a big except, all right? So this is an except. So the only time there'll be an exception to this rule, except if the scalar is a scalar quantity is negative. Then the direction will change. Okay, so except if it's negative. So for instance, let me give an example. If for instance you have k multiplying x and y, two components, for instance, we've already agreed that this is going to give us what? Kx and ky. So you can see it's still in the positive direction, or it's still in the same direction. Because remember, in negative, they have to go in the reverse direction, right? So that means it's still maintaining. But if you have minus k, x and y, your final answer is going to be what? Minus kx. So you can see that means the direction of x has what? Changed in the opposite direction. And it's going to give us minus k what? Ky. All right. So maybe let's pick an example and that will become a little bit more clearer. Okay. So let's say, for instance, we have this example here. Number one, we're told that let u to be equal to minus 1 and 8. Find 5u. Okay. So like I always say, I prefer to write mine in column form. So I can now say u is the same thing as saying minus 1 and 8. Okay. So we're looking for 5u. So 5u is going to be the same thing as saying 5. The u is minus 1 and 8. Okay. And that'll be equal to 5 times minus 1 and 5 times what? 8. And this is going to give us 5 times minus 1 will give us minus 5. 5 times 8 will give us what? 40. And that will be the answer for that. Okay. So the next one. Let's see. Let me add one more. Okay. So number 2, we're told if A is equal to 4, 5, 7, okay, and B is equal to 2, 3, and 1, okay, we're told to find 10A and 4B, all right? So, as usual, we're looking for the first one. We're looking for 10A, which is going to be the same thing as 10 into bracket, just to be, this should be capital letter. This is 10A, okay? So it's going to be 4, 5, and 7, okay? And that will give you 10 times 4, 10 times 5, and 10 times what? 7. And that will give you 10 times 4 will give you 40. 10 times 5 will give you 50. 7 times 10 will give you what? 70. And that will be the answer for that. Okay. The next one, number 2, the B part. We're looking for 4B, 2, 3, 1. Okay. B, we're looking for 4B. And that will give us 4. And B is what? 2, 3, and 1. Okay. And that will give us same thing. 4 times 2, 4 times 3, and 4 times 1. And this is going to give us 4 times 2 will give you 8, 4 times 3 will give you 12, 4 times 1 will give you 4, and that will be the answer for that. Okay, so that is how you do it. So you just basically open the bracket, similar to opening the bracket in scalar multiplication. And that is how you solve more questions. So you'll see more examples. We're going to talk about vector arithmetic soon. All right. So we're going to do more examples on this. All right. So the next video, we're going to talk about arithmetic now. So we're going to do how do not combine multiplication, scalar multiplication, addition, and subtraction. So something like that. So we're going to do scalar multiplication, addition, and subtraction in the next video. So like in this, we usually did scalar product or scalar multiplication. In the previous video, we talked about addition and subtraction. So we're going to talk about arithmetic, where we're going to combine both scalar multiplication, addition, and subtraction. Okay. All right. So I'm going to see you in the next video. That will be that for this. And if you have any question, please don't hesitate to contact me or send me an email, and I'll get back to you as soon as I can. All right. See you soon.